messed it up. Yeah, seriously. Yeah, I didn't ever pay attention to what day it was.
All right, guys. So I want to say a couple things real quick about um, how this class is kind of structured. So if you guys noticed, chapter 1 was exciting. It had all the, you had to know what the hell the words meant that we're going to use. Okay, that chapter kind of makes sense. What words we're going to use. Chapter 2 is all about, okay, once you do this sample that we learned in chapter 1, the word, and you start to look at it, how do you represent to people what you found? So one of the basic ways is histograms. You can do it with numerical data, right? 2.4 and 2.5 are all about making other types of visualizations of data. 2.5 specifically is about how can you lie with statistics, and how can you make it so you're not lying, right? So 2.5 is all about can you tell what's wrong with the way they did this, and then can you correct it to make it better? That's what 2.5 is all about. Chapter 3 is going to be, okay, great. I've shown people what I see from my sample. I want to get in there and really start to analyze it. Start taking averages and start doing other things, statistical calculations on this, and trying to interpret what that means. Cool? So chapter 2 is all about just showing people what I see in my sample. Chapter 3 is about really getting into it and working with it and doing something with it. Okay. So we're going to finish out 2, and we might get a little bit into 3. Well, maybe we'll finish out 2. And we're not going to do everything in chapter 2. We're going to do in section 2.4. We're not going to do every single type. We're going to do the most popular types. Specifically, we're going to look at dot plots, stem plots, and scatter plots, all kinds of plots. These are really quick ways, without truly analyzing it too much. It's really quick ways to get a visual of your data. So they sound easy, and thank God they are easy. They are pretty easy. So what do you think dot plots uses? Dots in a plot. I love it. So dot plot, let's see. So let's say I had this kind of data. My data was, let's do the number of words typed a minute. Right? So here's my data. And let's say I have, somebody did 30 words, 35, 30, 25, 40, 40, 35, 35, 40, 40, 50. Okay, I'll say that's my data. So I'm going to let you guys copy it down. A real quick word too, every visualization works a little better, of course, with a larger sample. But in order to do these kind of quickly, to get you the idea, I'm going to have to use smaller samples. Yeah?
Does that say number of words per minute?
Yeah, words a minute, yeah. That's like a division, sorry. But words per minute. Is
on the homework, they were kind of do dot plots, but they had like some less precise, easy fitting numbers like 31, 32, 33, 34, 35, the entire spectrum up there. And are we going to go into what you would need more detailed circumstances?
Yeah, dot plots, you'll see in a minute, dot plots work the best with data that has repeats in it. And you'll see why here in a minute. So I think the homework gives you some that have repeats. I'm not going to give you any that don't have repeats. You'll see in a minute why it would make very little sense. It would make a little bit of sense if there were no repeats, but it makes more sense if there are repeats. So notice what I was very careful about here. I have repeats. So here's how a dot plot works. You make a scale to fit all your data. So in this case, obviously, I want to start with 25 and go up to 50. So I want to go by fives maybe. Okay, cool. Now, like you're saying, there might be some where there's 36, 42. You just put them in the right spot. So now you just put a dot every time, and don't cheat. The height of these dots, it's sort of like a very quick histogram, and you'll see what I mean here in a minute. If I do at 25, there's 125, right? So I put one dot. So obviously if I have a big list of data, the first thing I'm going to do is sort that bad boy, so it's easier to find stuff. Let's see, 30, there's 1, 2, 2 30s, right? 1, 2. 35, there's 1, 2, 3, 3 35s. 40, there's 1, 2, 3, 4 40s. 45, there's none, and 50, there's 1. So that's a lot quicker than it would be to create a histogram. A histogram here wouldn't really make too much sense anyway, because there's really, there's not much data there in the first place. How are we doing so far? Does that make sense? But this is a very nice, quick visual. Would you say that this looks roughly bell-shaped?
Yeah.
Very roughly, because here's what's called, the bell curve, and what I'm going to call from now on the normal curve. Okay, and the nice thing about the normal curve, and I think I've talked a little bit about this before, heights are a really good example of something that follows a normal distribution, a normal curve. Because most of us are near the average. Very few of us are crazy tall or crazy short. So if you actually do take a large sample of the population and plot their heights, you will get, almost always, a pretty normal curve. This is, considering it's a very small sample, it is very loosely normal. Because it starts low, goes high, and goes back low. Now this going back low is pretty quick. That's why I say it's loosely normal. It goes high and then back low pretty quick. You guys with me? So there will be questions, and you've seen them already in the histogram section, asking you, once you make your histogram, you can step back and say, does it look like a bell shape? Or does it just go up and never come back down? So it's not normal? Okay. How do you feel about dot plots? I mean, you don't have to draw this little dude here, but it is normally distributed very roughly. Stem plots. Something I'm used to calling a stem and leaf. Stem and leaf plot, not exactly a phrase you expected to hear in statistics class, I'm sure. But the way it works, there's stems and there's leaves. So what the hell do those have to do with numbers? And actually, let's just use the same data. Not the most exciting data, but I've got it here, so what the hell? The stems are the first part of the number. And you actually have a lot of flexibility if you have decimal numbers, if you have large numbers. You have a lot of flexibility in what you want your stem to be. In this case, it's pretty straightforward. My stems are like 2, 3, 4, 5. And the leaves are the options for the second digit coming off of that. So my stem plot will look like this. 2, 3, 4, 5. And after 2, I would just put a 5. After 3, I would put 0. 1, 2, 3, 5s, right?
There's two 30s.
1, 2, 3.
2 30s.
Oh, 2 30s. Oh, yeah. 1, 2, thank you. After 4 would go 0, 0, 0, 0. And after 5, just a 0. How do you feel about that? Yes, ma'am.
If there's like a bunch of decimal places like 0.08, can you round up to 0.1?
It depends on the situation. I mean, let's do another example that's a little more complicated, okay? Real quick, before I get too far. Do you see how this kind of confirms the normal distribution? It's a very small sample, but still, it kind of goes high, goes back low. It's only got 4 classes, though, right? So be careful about making a stem and leaf and then taking that directly to a histogram. There might be just 4 classes. That's not enough for a histogram. The last thing is, this could be 2.5. 3.0, 3.0. I've got to tell people what it means. So I take one example, like 3.0 means 30. This is my key. So people know how to read the whole thing. Is that cool? Because that same stem and leaf could represent 2.5, 3.0, 3.5, so forth. Okay. So let's do something with some decimals. So I kind of did this on purpose. This you definitely wouldn't want to round. And you guys kind of see why. If you round this, a lot of these would become the same as the other ones. When actually, when all my data is so small like this, I have to preserve what little difference there is. You guys kind of with me? This could be huge, by the way. I mean, actually, what did I do with that one? I only went 2 decimal places there. Make that a 1. This kind of difference here between 21 and 24, it could be huge. 21% chance versus 24% chance, that's not huge, but it's still, I want to preserve that difference. I don't want to make them both look like they're 20%. You guys got it? So relative to the data, that second decimal spot is necessary. Right? When I was a little kid, if something cost 1 cent versus 10 cents, okay, that's huge. Especially when I was a little kid. Nowadays, I don't know how much money little kids run around with. But to me, 1 cent versus 10 cents was huge. If I had 10 cents, watch out. Right? So here I've got to present, especially when the data, all the data is in it. Now, if I had like 1.7, 0.5, 1.9, and I had one that was 0.48. Only one of them was 2 decimal places, and there was pretty big differences. Then I can make that a 0.5 and not lose anything. But when all the data is this small, or hovering around the same place, I don't want to lose that information. Cool. So how would I make this? Who's got a suggestion as to how to make this stem and leaf? What do the stems seem to want to be here? It can't be 0, because then I'd have one stem with a bunch of leaves coming off of it, and then what's that? What good is that?
The 10th place?
Yeah, this guy, this place here. Because it would be 0, 1, 2, 3. And then the leaves can then be the second decimal place. So off the 0 would go, let's try to put it in order at the same time. 1, 6, oh, there's a 5. 1, 5, 6, 8, 9, 11. Thank you, guys. And then after the 1 would come 4, and 5, and 8. Oh, yeah. After the 2, 1 and 4. And after the 3, poor little 1 dude. Yes, sir.
Can you put a 0 point in the stem area?
Yeah, you could, and in fact I've seen it, and in fact I think this book might do it somewhere, but it's not necessary at all. Because how do you take care of that? Because right now somebody looking at this might think this means 14.
In the key?
Yeah, the key says, just pick an example, 1, 5 means 0.01, no, too many zeros, 0.15. Cool. You guys cool? So don't lose points for getting a key when you make this kind of plot. Yeah.
And why do we want to use stem and leaf plot?
Why would we want to? 2 things. It's a very quick way to sort your data, especially if it's not a huge set of data, if you have to do it by hand. Secondly, you do this, and it gives you a really nice visual of the data. Does this look anywhere near normal? I know it's only 4 classes, but who cares? It's high and it goes low, so I get a very quick visualization, and I sort the damn thing at the same time. So the Stemleaf is actually still used. The more, of course, we get into computers doing everything for us, until they become our overlords, the less you see this kind of thing, because people forget how useful it is by hand, but I'm trying to preserve it. It still is used. Okay, cool. And the last one, is everybody cool with the dot plot? I mean the Stemleaf plot?
Oh, man.
Yeah. Oh yeah.
Like 1.0 something.
Oh, if this data would have gone up to 1.0, that would still, if I would have had a 1.07 or something. Now here's where you gotta be careful. Let's throw that in the mix. And that definitely throws us off here, doesn't it? But then what would that be here? Now the thing you gotta do, you gotta realize, you can't skip anything or else you're being misleading. If this is supposed to be a quick visual and you put the answer here, it looks like it's all grouped. When actually there's one number, and of course I run out of room, way at the bottom, so you guys, I think I made the point, you gotta show everything. Get down here to 10 and you put your 7. You guys semi with me? What would really truly happen here is that is so out of whack with this that I go back and say, shoot, did I mean 0.107 and then rounded to 0.11? Did I read something wrong? It's just so far off. This is what we call an outlier. Every time I say that, I always think about Children of the Corn. Everybody ever seen that original? Yeah? When the guys, Outlander! Walking through the, yeah. The rest of everybody's like, I don't know what the hell you're talking. Every time I say outlier, I always think about that scene. Outlier, we have your woman. Watch the movie. Maybe watch it on non-cable channel, so it's nice and edited. Watch it on Netflix. Netflix, yeah. Oh, so the last thing, scatter plot. I think this will be the last thing we talk about today. Yeah. Scatter plots, you guys have done a lot of them already, believe it or not. Every time you've ever made, for a teacher, like an algebra class, they said plot the following points. That is a scatter plot. We just don't call it a scatter plot. In algebra, we call it that here. So this is for paired data. And what I mean by that is, I'd say, maybe I'd say something like, how old are you and how much money do you make? How old are you and how much money do you make? So I'm trying to, what do you think that kind of study would be trying to get at? How old are you, how much money do you make?
The relation of age and.
Yeah. As you get older, you probably should, until you get to a certain point, you probably should be making more money possibly. And of course you got some outliers there too, like Zuckerberg or Gates made a lot of his money early in his life, right? But mostly it should follow some kind of a path. And that's actually the whole point of this, is if we can do it visually, we can see if there's a trend in the data. So if we do, one of my favorite paired data is to do, you'll see when we get to chapter 10, is how many beers did you have last night, and what grade did you make on your 7 a.m. test, right? So I had 1 beer and I made a 89, and I had 3 beers and I got a 74. And you're still gonna have the outliers. I had 5 beers and I still made a 92, So then you just plot those like always, right? It's really just Cartesian coordinates. It's really just rectangular, x, y, not a big deal. This x could be anything now. In this case, what would the x represent? In this case, number of beers, and the y would be grade in your test. Exactly. I love it. You with me? So then you do. So this seems to be, you need all that. 1, 2, 3, 4, 5, and then I make this scale intelligently to fit all this stuff without skipping anything, and you want to make it consistent. I'll get this kind of thing all the time. 74, 89, 92. I make a straight line. That's not good. So let's just skip some space here. 70, 80, 90, 100. Is that cool, everybody? Just to fit it on my whiteboard. And you can skip space, especially when it's not misleading, when it's not. So when we get to 2.5, we'll talk more about that. But you can skip space because all my data right now is right here. So who cares about 0 through 60? Thankfully, nobody seemed to fail this test out of my 3-person class. So 189, 374, 592, and let me just, is that cool? And let me just make up some data real quick. Of course, you know. It's not going to go like that in real life because there are people that no matter how sober they are, they're going to fail the test. And there are people that can hold their liquor pretty good and they're going to be fine at 7 in the next day. But there should be maybe some kind of an effect. Because if you wouldn't have drunk so much and you have a 7 a.m. class and you got a big test, you might have done better. So we should see some kind of a trend. And I've kind of overdone the trend here, but what would you say the trend is? Especially considering that outlier gone, the trend seems to be downward trend, right? So a lot of times in our analysis, we have to identify the outliers and possibly take them out. Not totally delete them. Say in our write-up, this is an outlier, taking him out, we see a good trend. We're not sure what's going on with that outlier, blah, 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 blah. In this case, we know it's the guy that can hold his liquor well, doesn't get hung over, and knows his shit. Right? That's this guy. And who's this guy? He had half a beer. And he still made a really bad grade. Cool little dude. He's down here in the schoolboy area. I don't know. All right. So next time we'll finish 2 and get into 3. I'll have your other quiz graded.
I just have a question about this.
So if you have a calculator, fine, please think. Oh, the Thanksgiving.
Yeah, 20, so in the context of the measured data, what issue can be identified by doing statistical analysis of the values?
The only mistake you made here is it makes it sound more, you actually didn't say it as bad, but it makes it sound like the weight directly affects that, and you don't know yet.
Well, I thought that's the issue is whether it does or not.
But actually you could say whether increasing or decreasing gas mileage makes the car heavier or lighter. You could say it the other way too, which actually we kind of know doesn't make as much sense. But before we enter the study, and it's not a huge deal to tell you, honestly, you would say whether there's a relationship between low gas mileage.
Got it.
And it's not a big deal.
Okay.
But you gotta be careful about stating it that makes it sound like you know the cause and you know the effect.
Okay.
Yeah.
So, just these 2 correct, or is there, okay?
Those 2 are good.
Okay, that's, is that okay?
And then, yeah, for the quiz, were you saying that this one was okay? Because you have the little question mark.
Yeah, I didn't take points off, so let me see.
Because like the number.
Oh,
the number
well, I was expecting the nominal answer, but they would have an order, so I'm kind of thinking if you go a little further with that, because they kind of do have an order, but some people are telling me not really, because it depends on what your issue is. And
Right. Yeah, that's what I was thinking.
Or if you see people said ordinal because they take you in a certain order as you come in, that makes sense too. Yeah. So I was just underlining that saying, you know, a little further would have been
and then this one
better.
fixes basically just because different types of cars, and you can fix on like the same car.
Yeah, because we're not looking at that, we're looking at that.
Uh-huh.
That would be nominal. The percentage is not a
Not what
data
we-
point. So I can't even say if it's ratio or whatever, it's just what I did.
Oh, okay. So I was
There's
thinking
the
it's like,
data.
let's say 24% drove Hyundais, 12% drove BMWs. and
That'd be
the
twice
ratio,
as much,
because
exactly.
twice as many people drive Hyundais.
But my data is car names.
Oh, so how do you look at that? Or, like how?
You realize the
figure that out?
percentage is it's something I did with the data, so that means I don't know what data is yet. What did I do that 20% with? BMWs, Hyundai, so it must be, the data must be the names. not the percentage. The percentage is what I
Oh,
did with the
okay.
data.
How would it be ratio, is it vice versa? Like BMWs would
It'd be ratio if I would've
20%
said,
people?
if I would've said there were 10 BMWs in the first lot, there were 5 BMWs in the second lot, there were 20 BMWs in the third lot. You see how now my data point is number of BMWs in a lot?
Uh-huh.
So now that would be ratio, because if there are 10 there and 5 there, there are twice as many there.
Oh, okay.
So my data point in that case means the number of BMWs.
Okay.
What's my data here? Type of car.
Okay.
You said you were gonna, I emailed you last week, so you're gonna give me a quiz, the copy of the quiz?
Yes, cool. You want with you, bud?
Yes, please.
And
Do you
if
have
you
to
can see
turn
what it
the,
looks like.
do you have to turn the practice test for pre-calc?
You don't have to turn it in,
Alright.
because we gave the answer key.
Are we taking pre-calc
Yeah, but I-
and this at the same time?
On me? I don't know if
Are you taking pre-calc?
Not on
at
here.
the same time?
Yeah.
Why?
With him. Because I'm insane. I'm trying to look up. Did I word it
Oh,
wrong? Or-
so I needed more like why can't it be experimental? And I was okay with this,
Yeah.
because you have the effects of the chickens. But you still kind of look to see, right?
Right.
So here, I always need a little bit more, we don't want to influence their behavior at all, so that's why it must be observation, not experiment. So of course we want to observe them, but we always want to observe what's going on.
Right.
The difference here is I don't want to do anything to them, I just want to see what they do naturally, not with me in there doing something. If they see me watching them, they're gonna act very different from the way they normally would. It's like, is that gonna be the cops or something?
Oh, okay.
Yeah,
Okay.
cool.
How do we go about doing the test, the quiz corrections? Do we just,
So I'll never change the original.
well.
On another
not-
sheet of paper or on the back, just correct all the
And
ones
you
that
don't
you
have like
lost
a
points.
special form or anything?
No.
Okay, and also, the question that said it was, you pick which kind of data it is or whatever, and, it's the one that said like 13% strongly agree, this
Oh, yeah.
percent disagree.